Okay, let's look at another question. Limit n tends to infinity n factorial raised to 1 by n square. So in order to solve this, we have n raised to n. Will there be equality also? Where if I consider n equals to 1, okay, so there will be equality. So n factor is always less than equals to n raised to n. If I take power on either side, 1 by n square, 1 by n square. Okay, so now one more thing to notice, this n factorial raised to 1 by n square is always greater than equals to 1. Okay, so we can justify this inequality. If I take n equals to 1, so 1 factorial will be 1 upon 1 by 1 square means what? 1. So for n equals to 1 we will get equality. What happens if I take n equals to 2? For 2 I will get 2 factorial raised to 1 by 2 square means what? 4. So 2 raised to 1 by 4 means what? So 2 raised to 1 by 4 like 1.18 something. Okay, so it's still greater than 1. For 3 again we will get 9 by 1 by 6, which will be again greater than 1. Okay, so this justifies this inequality. Again, if I consider on right hand side, n square raised to 1 by n square, this n will cancel. I will get n raised to 1 by n. Okay, so now approach n tends to infinity. Okay, so what will happen if I n tends to infinity on both the side? So limit n tends to infinity 1 less than equals to limit n tends to infinity n factorial raised to 1 by n square, and this side we have limit n tends to infinity n raised to 1 by n. Okay, and what is the value of n raised to 1 by n? So this is equals to 1. Okay, so limit of constant function is always 1. Limit n tends to infinity n factorial raised to 1 by n square, and this is we are getting 1. So what we are observing here? We are observing here it's left hand side and right hand side is both 1. So what comes in your mind? Obviously sandwich rule. Okay, if my left hand side and right hand side limit both are same, then middle one has to be 1. Limit ends to be n tends to infinity n factorial raised to 1 by n square has to be 1. Okay, so this is by sandwich theorem. Thank you.